Okay, now in this section we'll see how to configure the default routing and when and where exactly we use default routing. Now default routing is used in two scenarios, and the first scenario is for unknown destinations. So if you want to route any packet to any unknown destinations like internet, we use default routing, and also it can be used at the end locations. So there are two scenarios where default routing is used. Let's try to get into more in detail on these two scenarios. So the first example is, so I'm going to with the first example, as I said, it can be used at the for internet. If you want to route any packet to internet for any unknown destinations, we use default routing. Let us try to understand how it's going to work. So let's take an example. I got three routers, and these three routers are belonging to my different branch offices. I'm using 192.168.1 network and 2 network and 3 network, and all these three branch offices are able to communicate with each other based on the static routing what we did in our previous scenarios, and everything is working fine. So if any packet is destined from 1.1 to 2.1, it's going to work, and also any packet destined from 1.1 to 3 or 3 to 2, it's going to work. So I already have the static route configurations. If you want, you can go and verify on the router 1. I can give a command called show IP route to verify. You can see I already have the static routes and everything is working fine as we did in the previous example. So now let's take an example. This router 3 is connecting to my ISP service border, and then from there it's going to connect to some internet. Okay, so from where I'm able to access my Yahoo, Google, Gmail, something like that, some internet sites. Now I'm on 3.1. Now the user is sitting on 3.1 here, so 192.168.3.1 here. Now this user is going to send a request, and it's going to send a request to yahoo.com. He says he want to access www.yahoo.com, and he's going to enter the URL path, and the source address will be 192.168.3.1 from where the packet is coming, that is from 3.1 computer, and the destination is somewhere on the internet here. There's a Yahoo server, assume, and the IP address of that Yahoo server is 202.111. Assume this is the IP address, some public IP on the internet, and the destination is 202.111. So whenever any packet comes from 192 network, here it is 192 network, and the destination is 202 network, which means they are on different networks. So whenever a PC realizes that it is on different network, it is going to forward the packet to the gateway. So which means that it enters the router, and what the router is going to do, it's going to check the routing table, show IP route. It will see whether there is an entry for this destination in the routing table or not. If there is no entry, what it is going to do, it's going to simply drop the packet. So let's verify whether there is an entry for that particular network or not. So you can go to router 3 to verify. If I go to router 3, if I give show IP route, now the router 3 is having an entry for 192.168 1 network and 2 network and 3 network, but there is no entry for 202 network, which I discussed. So which means what happens? So let's verify. If there is no entry, anyway here I don't have a real internet, but generally what happens is if I try to ping from one of the PC, that is 192.168.3.1, and I'm trying to ping to some address which is not present in my network, or it's going to simply, the reply comes from the gateway, that is 192.168.3.100, and that 3.100 says that it doesn't have an entry, so it's going to simply drop the packets. So in this scenario, what I want is, I want to ensure that if any packet is coming from 3.1, if it is destined for 202 network, which is somewhere on the Yahoo here, I want this packet to go to the router, and from the router I should forward the packet to ISP, and from the ISP it should reach the Yahoo server and the reply should come back. But in this scenario that will not happen because there is no route in the routing table. So if you don't want to drop the packet, then we need to write a route. You need to go to router 3, and then we need to write a route saying that IP route destination network entry. We write a static route. If any packet is destined for 202.111, we need to tell that send it to 2.2.2.2. assume the IP address of this router on the ISP is 2.2.2.2. I'm going to tell that send it to 2.2.2.2. So which means now if any packet is destined for Yahoo server, which is 202.111, will be sent to the router, and the router is having an entry for that network. It will forward it to 2.2.2.2, goes to ISP, from there it reaches the internet and it will communicate like that. But let's take an example. The another user in my network want to access something called some other website on the internet, google.com or some other website, and the IP address on that Google is, let's say, 50.1.1.1. Again, the same thing happens. The packet goes from 3.1 to 2.1, and the destination network is 50.network, and there is no route in the routing table. It's going to drop the packet. If you don't want to drop the packet, we need to add one more static route saying that if any packet is coming from 50 network, send it to 2.2.2.2. But now the question is, how many static routes can you write? Because on the internet you have thousands of networks, and it's not an easy job. It's not at all possible for you to write the static route for each and every network. Now in this kind of scenarios, what we need to do? So because if the router do not have an entry, it's going to drop the packet, and again writing the static route for each and every network is not possible. So what's the alternate solution for us? Now there is an alternate solution called default routing. Now what I can do is I can go to this router 3, which is connected to internet. I can write one default route, and I can say that IP route 0.0.0.0. Now the meaning of 0.0.0. means it can be any destination. That's what it says. And then I can write 0.0.0.0. It can be any subnet mask. So which means in place of destination network ID, I'm writing all zeros, and in case of destination subnet mask also I'm writing all zeros. Simply send it to 2.2.2.2. So I'm not writing this. I'm not writing these entries. Instead, I'm going to write one single default route. Now once you add this entry in your router, you'll see something called S asterisk 0.0.0.0/0 via 2.2.2.2. So we'll see this practically more in detail in our lab scenarios. But once you add this entry, now what happens is, now if this user 192.168.3.1 want to go to 202.111, which is on a different network, the packet goes to the router. Now the router is going to check the routing table. Now it doesn't have any entry for 202, and instead of dropping, it's going to see the default route saying that my administrator said that if any route is destined for any unknown network, if you don't know, instead of dropping, send it to 2.2.2.2. So which means it will reach the ISP, and then ISP knows better where is Yahoo, where is Google. So it will ensure that it reaches the packet to that particular server, and then your reply will come back to the ISP router, and ISP will reply back to your router, and then it will come back here. So that is how default routing is going to help us to route your packets on the internet. So remember one thing, whenever any packet comes on the router, if there is no destination entry in the routing table, it's going to drop the packet. So when you're adding default route, we are saying that if you don't have an entry, don't drop it, send it to this route, send it to ISP. So our job, now the user sitting in my LAN or my router don't know where is Yahoo, but still I will be able to communicate with Yahoo, because my job is, if I don't know where is Yahoo, I'm not, instead of dropping, I'm simply sending it to ISP, and ISP knows better where is Yahoo, and then that's how we can communicate with the different networks on the internet. So remember one thing, whenever you want to route any packet to internet, you must use default routing. So default routing is the one which we use. We don't use static, because adding the static routes is not an easy job, and we don't even use dynamic routings between them. There is one option called BGP, it can be used, but that is something a little bit beyond the scope of your CCNA exams. Okay, but majorly we use default routing. So we use default routing is mandatory, we need to use if you want to route any packets on the internet. So this is the first scenario where default routing is more applicable. So let's try to understand one more scenario where we can also use default routing optionally. That is, the second scenario is end locations. We can use at the end locations. So let's take an example. I got my head office, Let's say I got some routers here. Router A, let's give some name as router A, router B, and then router C, and then router D. So I got these 4 routers connected, and then I got more routers like router E, and then I got a router F, and then I got router G here. So assume that this is how they are connected. Now from the router E, I want to go to A. So let's take an example. From the router E, I want to go to so and so destination. So we are going to write the via path, via which source or via which route. So from the router E to reach A, anyway you have to go via A, right? And from the router E, if you want to go to B, C, D, F like this. So from the router E, if you want to go to A, you should go this route. There is only one route. But from the router E, I want to go to B, I have to go via A only. After that, either I can go from here or I can go from here. That's a secondary thing, but you have to go only via A. And from the router E, I want to go to D. I should go via A only. And from the router E to go to C also, I have to go via A only. Either I can go from here or I can go from here like this. Now if you just try to see here, to reach all the destination, there is only one common next hop. Even if I want to go to A or to go to D or to go to F, I have to go via A. So in my scenario, from the router E, this is a common next hop to reach all the destinations. Okay, so one option is I can write multiple static routes. There is one option. Or what I can do is I can simply configure, I can simply go to this router, I can simply write, or I can say IP route. I can say something like 0000, whatever be the destination, whatever be the subnet mask, and the next hop address is A. So instead of writing multiple static routes here, what I'm going to do is I'm going to write one single default route saying that wherever I want to go, I should go via A. So why I need to write these many static routes? So if you write, there's no problem. It's going to accept, it's going to work. But on the end locations where you just have only one common next hop, where you got a common next hop and there's only one next hop, and to go to any destination it's a common next hop, so it's simply we can write a default route. So this way we can minimize the size of the routing table because we don't need to add these many entries. It's going to minimize the manual configurations. Instead of writing static, we can use default route, but you cannot use default route again on the router A because router A is having 3 connections, 3 links, and you cannot say default route 0000 on all the sites. Okay, you can have like you can have 2 static routes and 1 default route, that is okay, but you cannot have all the default routes again. So default routes are more applicable if you have one common next hop to reach all the destinations. Now the same rule is going to apply here, the same rule is going to apply here as well. So optionally we can use default route at these end locations. Okay, so more on this default routing like implementing and verifying, that we'll be seeing in our next video.